technology to product. Most people here are technology people. What's actually needed to make a product from that technology? That's the question. No, he said that it's better not to have one. Just okay. Speak loudly and it will pick it up. So if I'm whispering, please tell me. I'm a tourist. So, agenda. Who is ASCO? I'll explain a little bit what I want to talk about and what I want you guys to talk about. What the community gets out of this, because I'm a commercial guy, I'm a bad guy. And then brainstorm and smash my ideas.
The show's bad guy.
ASCO is a Swiss company, about 2,300 employees worldwide, but its main centre is in Switzerland. And it's a Swiss company, it's Swiss registered, you can buy the shares, etc., etc. Just the standard marketing slides which nobody reads. We're in 3 groups: wireless solutions, network testing, and security communications. You kind of expect I'm in the wireless, but I'm not. I'm actually in security communications. Because wireless solutions makes telephones, DEC telephones, voice over IP telephones, and the base stations for that. And it concentrates on a niche of hospitals, where there's a big emergency button on the top saying panic, or it can be in fluids and whatever. It's a niche market for voice systems in hospitals. Network testing, typically global leaders in testing GSM networks, UMTS networks, doing quality testing. How good is the voice you get out of them? And then there's the WBMv4, security communications. So communications for mobile, for military, for blue light organisations, so the police and fire brigade, civilian security, in tunnels, all sorts of secure communications. We have a number of products, which at the moment in the defence sector is 2 different sets of products, one for Switzerland and one for the rest of the world. It's, as usual, some history involved in that everything in the rest of the world was built in Finland, everything for Switzerland was built in Switzerland. And in the next generation of the hardware, it all comes together, because we closed down Finland. We do infrastructure stuff, we also do public safety. Anybody who's ever travelled around Switzerland will have seen these orange things on the side of the motorways. That's an ASCOM product. There's also the back end of our communications, how that works. If you ever go onto the ex-Swiss trail systems, the ticket machines are ASCOM products, and all sorts of weird things that ASCOM makes. Also, more on the public safety side, when you dial the emergency number, the guy that coordinates that sends out the messaging that people need to go somewhere. Another ASCOM product. We get all over the place in critical communication solutions. So why are we here for meshing? We're interested in heterogeneous networks. We have lots of different network technologies in our box. And we would just want to ask meshing as it's another network technology. We have EWO, we've got DSL, we've got copper and fibre. We now want to say, oh, we also do meshing as well. It's an IP router, it's a multicast router, it's a PBX. It's got analog telephony, it's got EWO telephony, it's got the Eurocom, which is a military standard for voice, telephony and data communications, etc., etc. We've been looking around for a while what mesh technology we use. We still don't know. We know the technology reasonably well. If we want it, we could just take the open source solutions, build it into the box and say we're done. Or we could go and talk to the various vendors and say, we want to license your product and put it inside our box. Still not decided. We're still open. What I want to know is, what do you need out of technology to make a product? Is the technology itself enough, or do we need user manuals? Do we need to fix the drivers, etc., etc.? What do the people who actually use these mesh technologies find when they're trying to use it? What's missing? So I'm really looking for more experience from using the systems. What do you as a community get out of this? I don't want it to sound like we're just here to soak up all the ideas, implement them, get rich. That's not our idea. You want to take part in the community. You know, I'm active with the development group, etc. Maybe we can coordinate ideas about who needs to do what. Maybe there's cross work between it. If somebody thinks the mad Wi-Fi driver helps everybody, etc. Maybe we can trigger off new interesting ideas, new cross projects. We can give money to people who actually do something that helps us. So it's both directions. And maybe we do the boring stuff like the documentation, which normal engineers don't want to do. See? If there's a benefit for us, we can do it. So, we will collect the ideas and make the ideas available on the battlemesh.org. Clients will type things away, I'll try and remember it, etc. So I'm going to go through 3 different use cases. Actually, the first case is no use case at all, I just won't throw it open. What's missing? What's needed to take the technology to product? Ideas. And just a few examples. All the commercial systems we've seen come with some sort of management UI to show the mesh topologies, allowing you to configure the links and things. Do you ever actually use them in the field? Is it needed? Is it just a marketing thing? Do you use them? Do you think it's necessary?
For the marketing.
For the marketing. So, in the field you wouldn't actually use it yourself? Or
if you have a single system that wants to monitor its network that he maintains, it will be helpful for him. But if he's a skilled person, he also helps in a sense.
I think this depends. If it's a technical guy who rolls out the network and what you want from the network. So if it's a technical guy, he may set up all by himself and knows what to configure and stuff like that. And if not, then global management view would not be so bad, so you can see it. The other thing is, what do you expect from it, or what kind of product do you have? If you just have little only antennas and just scatter around and that's it, and you don't expect too much from it, then you don't need to tune so much. But maybe you have multiple devices with many directional antennas where you have to set them out.
So that's also more like tools to help you pointing antennas, which is different from the mesh itself. That's a different category of tools, I would say.
Yeah.
And that again is generic to all meshing technologies. You just need somewhere to show the signal strength while you're sending packets.
Yeah, I think even in the community network, a topology viewer is always one of the most important things, even if the geeks or installers don't think so. Because the very first thing that users will do, where is my network? Can I see my network? I cannot see wireless, but I can look at the map and I can see the nice drawn, connections. And
so would you actually want to map that then onto a 2D map? So it's actually GPS based somehow, or just a random, just a topology? Is that enough, or should it map?
No, it should map it should be on the map, I think. Just a topology is really helping, I think.
So then you're actually into the location information as well, which is sometimes difficult. Yeah. So maybe we need to build the GPS into our box, is the question.
Probably an S-common product is not low priced, so
the GPS.
The money for a GPS module, including the up-to-date information where on the route it is Probably a piece of cake.
Yeah, or you give a simple tool to the user to store a GPS location somewhere connecting to a MAC address or something.
Other things that are required.
So I think here in the GriffyNet what they do is they have a map and the user clicks on the map where he is and that will create a location for the dot.
Okay, yeah.
And that will also generate some configuration and whatnot for this node because they see the neighbors and but that's what they are doing here, but just there's another way of doing it without having a GPS module. I think the GPS module is not the expensive part of the device. But indoors you might not have a signal GPS.
Yeah, indoors is a completely different sort of problem, which we've seen. Other things that make a product, other ideas.
I don't think that the mesh, at least for Batman Advanced, the mesh is the most simple thing. You just turn it on, maybe configure some intervals in the system. What is a little bit more complicated is the integration. You might have VLANs on it and different bridges off of it, and you also have the Wi-Fi configuration below.
So the complete network management of which the mesh is just a small part you can really forget about, per se.
Well, I think at least with Web Advanced we try to make the mesh as easy as possible to make it go away basically as a problem. So I tend to agree everything that comes on top of it is the real issue. Not so related to mesh itself. Support for our speaker.
Do the customers generally understand what meshing is? Do the customers need to understand that? Do you need to give education?
Sure. No, I don't think so.
We usually just say it will mesh around which are in range and produce a signal. This is enough for most people to understand and work.
And do you think the network administrators understand meshing sufficiently well that they can integrate that into a bigger picture? It's not just the end customer, it could be just a housewife wanting to go to the internet, it could be you've got to look at the bigger, who's setting up the network? Is the documentation there for that? Or
Well, to exaggerate a bit, I put my mesh node in the fridge so it stays cooler. Now I'm wondering why my internet upload is not working properly.
yeah. You need some basic information.
I think the basic information there is not so mesh related, but more Wi-Fi related. Yeah, where do I put my node? Where
radio related. Just not only Wi-Fi, just that many people are lacking some of the basic concepts. What are the essentials in wireless communication? And so it can be really helpful to tell them a few basics so they understand there are some trade-offs involved and you cannot get everything with wireless.
So information about what you can expect and what you can't expect on wireless.
Yeah.
The packet loss is going to be higher than what you normally expect. So this, it might be bad, etc.
yeah, line of sight and what is isolated the signal, and if I hide it between a window that has a double window with isolation in between, and surprise, doesn't work. So it's more the Wi-Fi layer that's the problem, I think.
Other general ideas?
Ateroscribe is still lacking support for the 800 speeds. That's something that needs to be addressed or fixed already.
Yeah, we have someone working on that. He is a student, he returned to the studies, so it's still working.
In his test that set up for 5 minutes, it was working.
Yeah. He said, hooray! When he got it, and he showed me that I can confirm that he had some big numbers in it, but it was just this table.
No, the decks were reviewed by other people.
Yeah.
What about Linux in general? Does everybody use Mac Wi-Fi, or do people use the internal driver, which is generally what's most stable at the moment?
If you use the BG hardware or ABG and those ones, you're using the Wi-Fi. And the newer ones are
The rear one has the advantage that you have a common interface to the wireless drivers, which is not Terra specific. So when you want to do a little bit more than just using the attack interface, querying about speeds, querying about data rates, then working with the new driver has several advantages because of this better defined interface, I would say.
Does it actually work properly? Do we as a community need to say, this is how we use it, this is how you should test it? I don't know, is it tested sufficiently well in ad hoc mode? Because I guess not many people actually use that.
I have an Ateros 811N card in my laptop. In ad hoc mode it works properly. Well, still lacking the 811N speeds. But I can suspect and presume it always works. And if I use the access point pilot mode, it stops every few hours.
Interesting.
There are also some glitches in the hardware for the 8810 supported parts and also in the driver. If you ask the developers, they say everything is fine, but we had some minor trouble, like the DMA stopping and not coming back or something like that.
So, do you think as a community it would make sense that we produce some sort of test specification of ad hoc mode or test scripts or...
Yeah, but there are, I think, test specifications from the Wi-Fi again. I don't know how good they are, but they at least do some kind of quality of service testing also. Like you have multiple notebooks and they should somehow equally split the screen, something like that.
It's more about kind of the Wi-Fi part and not the Linux part, I think.
Yeah, at least your driver should not crash while doing this test.
And they should actually perform.
Yeah.
Yeah.
That's hard.
Not can crash them all at once.
Are they choose one of it?
But do you think the Linux Wi-Fi community could do with help about how to use ad hoc or what testings they should do?
I think, unfortunately, it's not limited to a top mode. Even the station mode drivers in the Linux kernel are, well, experimental at certain point. And I think even if you have, for example, if that one chip, an ATH9K works somehow, it doesn't mean that ATH5K or other drivers work, because there's still a lot of stuff in between, or the Intel drivers. And I think in this field there are just very few people that work on drivers, and just a big black unknown. And that's why what we're facing is the biggest issue are the drivers.
Yeah. I think the situation became much better in the last years, but it's still far from perfect. Yeah, it's far from perfect. There are very little people in the at least from what I can say, if we see problems, maybe 5% are from Batman or from mesh network, and 95% are from Wi-Fi drivers. So we should probably mostly concentrate on drivers.
So we should help the wireless community. We forget about mesh for a while. Other things, ideas. If not, I can go into some more specific use cases and we can come back to this later.
Yeah.
Okay, Wagenberg, it's a German term which is hard to translate into English. It kind of comes, you can think about it as turning your wagons into a castle. You put them in a circle, you're inside and you're safe, outside is the bad world. You can imagine back in the Wild West, defending yourself from the Indians sort of thing.
Circle wagons.
Circle wagons. The military use this term as well. When they've got a group of vehicles, put them in a circle, or some sort of shape like that. And it allows them to get a defensive position. In Switzerland, there's a big core network based on the mountaintops. And the vehicles sometimes have microwave links that can connect up to mountaintops and gives them access to the backbone. And then in this circle of wagons, currently a soldier gets out, lays the fibre optic cable and plugs the wagons together. It's going to take some time, but it gives them a 100 megabits per second link. If they need to go anywhere in a hurry, they've got to jump out again, roll the cable up, throw it to the back. It's cumbersome. And then there's generally a VHF radio system which goes for a longer distance, but it's very narrow band. It could be 4 kilobits per second, it could be a bit more. What we're interested in is putting meshing into this so that a soldier doesn't necessarily need to jump out of his wagon and put live fibre optic cable down. The vehicle just drives up, you can see the other nose there, form a mesh. It can also extend the range a bit. We can move a few, maybe kilometre, kilometres away, depending on how our antennas are set up.
Just one suggestion. I would be very careful to suggest using Wi-Fi technology in this area because Wi-Fi 802.11 is trivial to jam.
Yeah.
It's designed to not to send something out there. So mesh technology, they might be interested in this, but when you want to have products, then you have to make sure that they understand what are the limits of the products.
In the normal out-of-war time, it's generally not an issue. It's during the wartime, then it will become an issue.
Even outside the war, I don't think they would be amused that their normal digital communication doesn't work because 5 guys with smartphones and active wireless LAN went close to them. So
the other thing is this bit. We can go into the license band with the military. We can get licenses, and that can help us a bit in that sort of area.
yeah.
They can still, people can block it. That's true. It's always true for any wireless technology. Somebody who tried hard enough to block this microwave link into the core network. Everything there is blockable. You just got to explain to the customer how easy or difficult it is to block this part of the overall system. Security is always an interesting thing in military networks. This fibre optic cable is completely unsecure. They rely on this guy with a soldier with a weapon. They don't care it's encrypted there. Whereas these links are highly encrypted because they go through the air. Security is always an interesting thing. I think that's one area where meshing potentially has a problem is how do we do the security aspects? How do we restrict who can join the mesh? How do we restrict who can see the mesh topology? Etc. etc. Which, as far as I'm aware, I don't think anybody's kind of looking too much at the security aspects.
I think which comes to my mind is the WPA not for ad hoc networks. I'm not sure if there's any security research on this. It uses some kind of static key and AES encryption, but it also lacks some of the features which the normal WPA has, like protecting from sending duplicates and stuff like that. So I don't know how secure this really is.
I think you must also take into account that there are different kinds of security you might want. When you just say I want to keep the bad guys out of my network, then something like protection from wireless LAN, which has some link layer encryption, might be enough. So sometimes you might need some end-to-end encryption, or when you say not making the topology visible, that's a contradiction in itself when it comes to mesh networks, because most mesh networks somehow get at least some topology data from at least the node needs an idea of the direction where the other nodes are. So if you don't have this, then it gets a lot more complicated.
Yeah, depends if you're in the mesh or outside of the mesh. If you can snoop the traffic and decode it, you can see the topology sometimes. If you're in the mesh, you've got the full access to the topology. The other thing is that sometimes the mesh node may fall into the hands of the enemy. So you need to be able to lock one node out of the network. So appreciate keys doesn't really work too well there.
And they have the problem how to run it. We have some, with at work we have some projects working on this. And it's a pretty complicated area that can be, depending on how high you want to ask the security, can be as complex as you want.
And the opposite side is the more complex it is, the harder it is to configure and actually use. It's getting the balance, the trade-off correct. Other ideas of what does needed in addition to the technology here to make a product, or is the technology ready to make this product? Something really interesting. Okay, another use case. One that ASCOM is not currently in, the things it wants to enter, is crisis management. Something bad happens, you've got to send all the blue light organisations, the fire brigade, the ambulances, the police. It's something that's similar to the military technology in terms of there's lots of different networking types involved, there's a heterogeneous communication system, there's links into the back link and so on. So you can imagine this sort of setup where the fire vehicles are all meshed together, the police are meshed together, there's networking between the various meshes, there's uplinks via satellite, so you hacked into the local McDonald's wireless LAN hotspot or whatever to get your backlink. Maybe you've got fire brigade with sensors on their shoulders telling them what's left in their oxygen tank, what the temperature is, what gases are flying around. You've got crowd management things, you've got cameras watching what's moving. Think about WEF or something like that. WEF is always held in Switzerland. So there is something like this at the moment there. There's other big events. But there's also the standard house fire, which also needs to be for use cases. These sort of organisations don't want to give out a lot of money for a once a year event. It has to be part of their normal, everyday life. How ASCOM sees itself different from the normal mesh companies is that most normal mesh companies generally have mesh and Ethernet and not much more. We intend to try and use the same sort of box, so we've also got the E1, the DSL, we've got the PDX, we've got all the other things in this box. And mesh again is just a small part of the overall product. We don't intend to try and compete with plain mesh companies, we want to be more heterogeneous, any communication technology. So what do people think is needed for this sort of setup? Does the technology we have here and now work for this, or does it need extending?
You need a good layer 1, layer 2 technology. Again, I think wireless LAN is not really perfect transmission technology for this kind of networks because it's not reliable enough. The fire brigade doesn't want a network that sometimes just doesn't work really well. So they say no, they want something more reliable. Wireless LAN has been designed to be cheap, to be nice to each other, and not to jam anything else. And that's, in this kind of case, that's a problem.
Yeah, that's why there's no voice here at all. We've talked to these people and they say, don't even think about putting voice over these networks. We don't want it. For us, Tetrapol does everything we need in terms of voice. It's more a case of, we can give them a best effort network, which probably works most of the time, and we've got to tell them that and to tell them that yes, it's the best effort network. And that often is better than what they've currently got. So it's a step in the right direction for them. It's better than having no meshing or no networking at all. I think the customer education about what can be done is a big important thing. Other comments, ideas, problems?
Well, if you think this is a best effort network and you think this is enough to resolve the security problems, which might not be so problematic in this case.
This could be worse.
Yeah.
Because you've got so many different organisations involved. You've got potentially no common point to synchronise with all your keys.
But your communication is more organized.
Yes, that definitely helps. It's certainly a different security problem. I think you probably end up building a security system for each use case. I think it would be very difficult to come with a generic security system.
But at least have some kind of modules, and you say, I don't need maybe in this scenario, I don't really need the encryption, but I need some kind of authentication so that people cannot spoof something like this. Or maybe some people say, yes, I need encryption too, or just say, no, I just get open because when we're doing this, it doesn't matter, but it must work well with the rest of the IP mechanisms.
Actually, blue light systems in Germany are not encrypted at all.
They are just in the process of getting this
falling horribly on their nose. Horribly.
It's just too complex for them to get it working correctly.
Yeah. If they run Tetra at all, they run it unencrypted because they cannot manage it. It's pointless. They spend millions and millions of euros and it's not encrypted.
But the same from the DECT telephone worlds. The first thing they do is turn the encryption off so that it can decode the DECT network. It always gets in the way. It's probably the same with GSM networks, we just don't know it. It's not probably not encrypted either.
Yeah, the first level of encryption is not encrypted.
Yeah.
Because nobody could afford the radio technology to get into one of these things. Today, they just don't get mounted on building high enough, so most people cannot reach the direction of it.
I think the major security problem which can come over is maybe the man-in-the-middle attack, as well as jamming of the response. Because that is not secure and
jamming signals is always possible. That's a problem.
I think this mission critical things, this thing, there's not very much to that.
The problem is, it's a question how difficult it is to jam. If you take something like Tether, it's more difficult to jam than a wireless hard card. And of course, when you go to the fire brigade, as soon as you move into the buildings, going to SHF frequencies is most likely the best idea because you have not that much range, and so your network will very easily fragment.
Our experience is that often the active one a GSM people station, because they've got GSM devices, often the sensors on the air tags, try and send SMSs every so often. when they deep down in the cellars, that doesn't get out. So what they would potentially like is a pico station. Then they can just point it at the building or on the cellar in the building. So that's something you could consider building into this, a pico station with a mesh node. And that kind of goes in your direction. Mesh potatoes and things.
If you sell this a best effort network inside it,
Yeah.
I think the routing is pretty much sorted out. I expect no ground breaking euro dimensions on that side.
But I don't think any of our current protocols with the standard settings would work well in a scenario with lots of mobility. Because this can be, most likely when you sell them a network like this, they want to stay mobile. So say it does only work when you are standing around but not moving, then it will get difficult to sell. So there might be some necessary adaptations or optimizations for us.
Not fully mobile in terms of they come to a site and then they're reasonably stable. So it needs to converge reasonably fast when they're all together. But I don't expect them to be moving around all the time. Or maybe there's one mobile person that's moving around. But then we're back into the more infrastructure meshing, which most systems can do.
Depends how many nodes would you like to operate in a single mesh cloud. Do you want 50 or maybe more?
I think we'll never have more than 50. My guess is, but nobody from product management has said, oh, this is the number, above that we can forget it. If you're going to go into more than that, then you need to start thinking about frequency planning and all those problems. Ideas? And just in case that brought up any other thoughts about general meshing,